Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0103, indicates a high voltage signal in the mass airflow MAF sensor circuit of the 2008 to 2012 Honda Accord. The MAF sensor is crucial for measuring the volume of air entering the engine, which helps the Engine Control Module, ECM, or Powertrain Control Module, PCM, adjust the fuel-to-air ratio for optimal engine performance. When the signal from the MAF sensor exceeds expected values, it triggers DTC P0103, indicating a malfunction. Understanding this error is important as it can lead to reduced engine efficiency and increased emissions. The MAF sensor is typically located in the intake air duct between the air filter and the throttle body. Analyzing freeze data and onboard snapshots prior to troubleshooting is vital to diagnose the issue accurately. The MAF sensor plays a pivotal role in measuring the air entering the engine, thus helping in the fuel mixture calculations. It is located in the intake system, specifically in the duct that leads from the air filter to the throttle body. This sensor helps the ECM/PCM determine how much fuel should be injected during combustion. If the voltage output from the sensor is higher than 4.89 volts, it may indicate a malfunction or a wiring issue, leading to DTC P0103. The sensor is connected to the ECM/PCM via a 5-pin connector. Understanding the position and wiring of the MAF sensor and its relationship with the ECM/PCM is critical for troubleshooting this DTC effectively. Several factors can contribute to DTC P0103 in the Honda Accord. A faulty MAF sensor is one of the most common causes. When this component fails, it may send incorrect voltage signals to the ECM/PCM, causing high voltage readings. Another possible cause includes wiring problems, such as damage, corrosion, or poor connections between the MAF sensor and the ECM/PCM. Checking these wiring connections is crucial, as intermittent failures can occur. Additionally, a malfunctioning ECM/PCM could misinterpret the signals from the MAF sensor, leading to this error code. Diagnosing each of these components thoroughly will help in identifying the root cause of the DTC P0103. DTC P0103 often leads to several noticeable symptoms in the vehicle's operation. Drivers may experience poor engine performance, which includes hesitation or stalling during acceleration. The vehicle may also exhibit increased fuel consumption, as an incorrect air-fuel mixture can lead to engine inefficiency. The check engine light will illuminate on the dashboard, providing a direct indication that a problem exists within the engine management system. Another possible symptom could be rough idle or engine misfires, further impacting drivability. Recognizing these symptoms can help in identifying the presence of DTC P0103 early on. Begin the troubleshooting process by turning the ignition switch to the on position, also known as I. Once the ignition is on, wait for approximately 2 seconds to allow the vehicle's systems to initialize. Next, check the MAF sensor data in the data list using the Honda Diagnostic System HDS tool. You're specifically looking for a value close to 202 grams per second, or a voltage reading of 4.89 volts or higher from the MAF sensor. If the readings meet these criteria, proceed to the next step. However, if the readings are below the expected values, it indicates an intermittent failure, and you should inspect the connections at the MAF sensor and intake air temperature IAT sensor, as well as wiring leading to the ECM/PCM. For the next troubleshooting step, ensure that the ignition switch is turned to the lock position, also known as 0. After that, utilize the HDS to jump the short circuit SCS line. This is important for any diagnostics involving the ECM/PCM. Once the SCS line is jumped, disconnect the MAF sensor/IAT sensor 5P connector. The IAT sensor works alongside the MAF sensor to provide accurate air temperature readings, which are essential for the ECU to estimate the air density and adjust fueling accordingly. Disconnecting this connector disconnects the sensors from the ECM/PCM, allowing you to inspect the wiring for potential issues. Now, proceed to disconnect ECM/PCM connector A, which has 49 pins. This step is essential for checking the continuity between the connectors without interference from the ECM/PCM. After disconnecting, you will need to measure the continuity between the MAF sensor, IAT sensor, 5P connector terminal 4, and ECM/PCM connector terminal A9. Having continuity indicates that the wiring is intact and not damaged, which is vital for the proper functioning of the MAF and IAT sensors. If there is no continuity, it suggests an open in the wire that requires immediate repair before further testing. Reconnect the ECM/PCM connector A that you previously disconnected. This reconnection is essential for finalizing the wiring checks before moving forward. Next, you will need to connect the MAF sensor/IAT sensor 5P connector terminals number 3 and number 4 using a jumper wire. This action essentially bypasses the MAF sensor and checks alternative circuitry to confirm whether the issue is with the sensor itself or the wiring leading to it. With this jumper wire in place, it allows the technician to isolate the problem, determining the areas requiring repair or replacement. After completing repairs, it is vital to verify the effectiveness of the work performed. Firstly, examine the repair results based on the continuity checks and any component replacements. Once satisfied, clear the Diagnostic Trouble Codes, DTCs, in the ECM/PCM using the HDS tool. This action resets the system and prepares it for any new diagnostic checks. Finally, conduct a test drive under various conditions to assess the vehicle's performance and determine whether the DTC P0103 reoccurs. If the check engine light remains off and the vehicle operates smoothly, the repairs can be considered successful. To prevent DTC P0103 from recurring, regular maintenance is essential. One crucial aspect is to routinely inspect the electrical connections pertaining to the MAF sensor and IAT sensor. Make sure that there is no corrosion, dirt, or loose connections that could result in erratic voltage readings. Additionally, it is advisable to clean the MAF sensor at regular intervals, as dirt and oil accumulation can disturb its operation. Using quality air filters helps ensure that the air entering the engine remains clean, thereby protecting the MAF sensor from contamination. Consistent preventive measures significantly reduce the risk of experiencing DTC P0103 in the future. In conclusion, understanding the role of the MAF sensor is crucial in diagnosing DTC P0103 effectively. Recognizing the symptoms, such as poor engine performance and the check engine light, can lead to early identification of the issue. Following a systematic troubleshooting approach ensures that all possible causes are examined, from faulty sensors to wiring issues. Furthermore, verifying repairs through proper testing and preventive maintenance can significantly decrease the chances of recurrence. Being thorough in each step guarantees that the vehicle functions optimally, providing the best possible performance while preventing unnecessary emissions. Please like and subscribe to the channel. See you next time.